This is the Edexcel Level 2 Certificate in Extended Maths, and this is paper 1 of the sample papers, which is a non-calculator paper. Question 1. f of x is equal to 4x plus 6. Part A. Find f of negative 3. Well, f of negative 3 can be found by replacing the x with negative 3. So we have f of negative 3 equaling 4 multiplied by negative 3 plus 6. 4 multiplied by negative 3 is negative 12. Adding on 6 to that, we end up with negative 6, and therefore f of negative 3 is negative 6. Part B. Find an equation for the line perpendicular to y equals 4x plus 6 that passes through the point 0, negative 8. To begin with, the gradient of f of x is 4, which means the perpendicular gradient is the negative reciprocal of 4, which is negative 1/4. And if we use y equals mx plus c, with the c equaling negative 8, we can therefore conclude that the equation of the line perpendicular to y equals 4x plus 6 passing through the point 0, negative 8, that's given by y equals negative 1/4 x subtract 8. Point A with coordinates A10 and point B with coordinates 3b both lie on y equals 4x plus 6. For part C, we have to find the length of AB, give your answer in the form c times square root d, where c and d are integers. Let's begin by thinking about the point A10. Let's substitute this point in to the line y equals 4x plus 6. So we have 10 equals 4 multiplied by a plus 6. We can find out what a is. Subtracting 6 from both sides, you will find 4 to equal 4a, and if I divide through by 4, you will find a to equal 1, which means a has coordinates 1, 10. Let's now think about the point B. Using the point B with coordinates 3b and substituting this point into the line y equals 4x plus 6, we have b equals 4 multiplied by 3 plus 6. So b is equal to 12 plus 6, which is 18. We can now conclude that the coordinates of b are 3, 18. With the point A and the point B, we can now find what AB is. So AB is equal to the square root of, well, we have the difference in the x's, 3 subtract 1 squared. Then we add on to this the difference in the y's, 18 subtract 10 squared. So let's simplify this. What we end up with is the square root of 2 squared plus 8 squared. 4 plus 64 is 68, and therefore we have the square root of 68, which is equal to the square root of 4 multiplied by the square root of 17. The square root of 4 is 2. We multiply this by the square root of 17. AB is therefore equal to 2 times root 17. Question 2, part A. For the first part, we have to simplify root 18. To simplify root 18, we can rewrite this as square root 9 multiplied by square root 2. The square root of 9 is 3. We multiply this by the square root of 2, and therefore root 18 is equal to 3 root 2. For the second part of part A, we have to simplify root 8 plus root 18 subtract 3. Let's deal with this root 8. Root 8 we can rewrite as root 4 multiplied by root 2. root 4 is the same as 2, and we multiply this by root 2, and therefore root 8 is equal to 2 root 2. And therefore, to simplify the result of root 8 plus root 18 subtract 3, well, we have root 8, which is 2 root 2. We add on to this root 18, which is 3 root 2, and then we subtract 3. 2 root 2 plus 3 root 2, that's 5 root 2. We then subtract the 3, and therefore root 8 plus root 18 subtract 3 is equal to 5 root 2 subtract 3. Part B. Rationalise root 2 plus 6 over root 8 plus root 18 subtract 3. Give your answer in the form a times square root b plus c over d, where a, b, c and d are integers. So, we are required to work this out. And what we can do to work this result out is use our answer to part A. Notice root 8 plus root 18 subtract 3 we found to be 5 root 2 subtract 3. So we can rewrite this as root 2 plus 6 over 5 root 2 subtract 3. And now for us to rationalise this, we need to multiply both the numerator and the denominator by the conjugate of the denominator. That is to say, we multiply this by 5 root 2 plus 3 over 5 root 2 plus 3. It's as though we are multiplying by 1. So let's work all of this out. We have root 2 multiplied by 5 root 2, which is the same as 5 times by 2. We add on to this root 2 multiplied by 3, which is 3 root 2. We add on to this 6 multiplied by 5 root 2. We add on to this 6 multiplied by 3. For the denominator, we have a difference of 2 squares. We have 5 root 2 multiplied by 5 root 2, which is the same as 25 times 2. We subtract from this 3 multiplied by 3. Let's simplify this as much as we can. 5 times by 2 is 10. We add on to this 3 root 2. We add on to this 6 times 5 root 2, which is the same as 30 root 2. We add on to this 6 times by 3, which is 18. For the denominator, 25 times by 2 is 50. We subtract 3 times by 3, which is 9. So if we work all of this out, 3 root 2 plus 30 root 2 is 33 root 2. Then we have 10 plus 18, which is 28. And then we divide this by 50 subtract 9, which is 41. And therefore, root 2 plus 6 over root 8 plus root 18 subtract 3 is equal to 33 root 2 plus 28 all over 41. Question 3. Here are the first few rows of Pascal's triangle. Part A. Using this information, expand e plus f to the power of 3. Because we are raising e plus f to the power of 3, we can find the coefficients by using the third row of Pascal's triangle. That is to say, we will be using the 1, the 3, and the 1. Therefore, e plus f to the power of 3, that's equivalent to 1 multiplied by e to the 3 multiplied by f to the 0 plus 3 multiplied by e squared multiplied by f to the 1 plus 3 multiplied by e to the 1 multiplied by f squared plus 1 multiplied by e to the 0 multiplied by f to the 3. And notice the power of e decreases by 1, the power of f increases by 1. So let's simplify all this. 1 times e cubed times f to the 0, that's e cubed. 3 times e squared times by f to the 1, that's 3e squared f. 3 times e to the 1 times f squared, that's 3e f squared. 1 times e to the 0 times f cubed, that's just f cubed. And therefore, e plus f to the power of 3 is equivalent to e cubed plus 3e squared f plus 3e f squared plus f cubed. Given that e plus f to the 4 is equal to e to the 4 plus 4e cubed f plus 6e squared f squared plus 4ef cubed plus f to the 4, part B, for the first part we have to work out 7 to the 4 plus 12 times 7 cubed plus 6 times 7 squared times 3 squared plus 28 times 3 cubed plus 3 to the 4. Well, what we can do is compare this expansion with the result here. And by inspection, you can see we have 7 to the 4. Here we have an e to the 4. Here we have 12 times 7 cubed. Here we have 4e cubed f. Here we have 6 times 7 squared times 3 squared. Here we have 6e squared f squared. Here we have 28 times 3 cubed. Here we have 4e f cubed. Here we have 3 to the 4. Here we have f to the 4. So therefore, you can see e is equal to 7 and f is equal to 3. And therefore, to work out what this result is equal to, we can use e plus f to the power of 4. So what we have then is e plus f to the power of 4, so that's 7 plus 3 all to the 4. 7 plus 3, that's just 10. So we have 10 to the 4, which is 10,000. So the result of this calculation is 10,000. For the second part of part B, we have to expand and simplify 2e plus f all to the 4. And notice that e has been replaced with 2e, and therefore we have to replace e with 2e in the expansion shown here. So, using the expansion, we have 2e plus f to the 4, that's equivalent to, well here instead of us having e to the 4, we would have a 2e to the 4. Instead of us having 4e cubed f, we would have 4 multiplied by 2e cubed f. Instead of us having 6e squared f squared, we would have instead 6 multiplied by 2e squared multiplied by f squared. Instead of us having 4e f cubed, we would have instead 4 multiplied by 2e multiplied by f cubed, and then we add on to this f to the 4. So let's simplify all this. 2e to the 4, that's 16e to the 4. And then here we have 4 multiplied by 2e cubed multiplied by f, that's 32e cubed f. Then we add on to this 6 times by 2e squared times f squared. So that's 24e squared f squared. We add on to this 4 times by 2e times by f cubed, which is 8e f cubed. We add on to this the f to the 4, and therefore 2e plus f to the 4 is equivalent to 16e to the 4 plus 32e cubed f plus 24e squared f squared plus 8e f cubed plus f to the 4. Question number 4. Part A, for the first part, we have to simplify 81 to the 3 over 4. 81 to the 3 over 4, that's equal to the 4th root of 81 all cubed. So the 4th root of 81, that's 3, so we have 3 cubed, which is equal to 27. For the second part of part A, we have to write 1 over 9 squared in the form 3 to the n. So we have 1 over 9 squared, and what this is equal to is 1 over, well, 9 is the same as 3 squared, and then we need to square this. So we have 1 over, well, 3 squared, that's 3 to the 4, and therefore 1 over 3 to the 4, that's 3 to the negative 4, which means 1 over 9 squared is 3 to the negative 4. Part B, we have 27 to the negative 2/3 multiplied by 3 to the 2y plus 1 multiplied by 1 over 9 squared multiplied by 81 to the 3 over 4, which is equal to 27. We have to find the value of y, and clearly what we can do is use our answer to part A to help us find the value of y. And also, to do this question, we can write each of the terms as 3 to the n. So, let's deal with the 27 to the negative 2/3. What this is the same as is 1 over 27 to the 2/3, and this is equal to 1 over, now here we have the cube root of 27 squared. So we have 1 over 3 squared, which is equal to 3 to the negative 2. The 27, that's equal to 3 cubed. So we have 27 to the negative 2/3 multiplied by 3 to the 2y plus 1 multiplied by the 1 over 9 squared multiplied by 81 to the 3 over 4, which is equal to 27. And using the results we've found, what we have is 3 to the negative 2 multiplied by 3 to the 2y plus 1 multiplied by 3 to the negative 4, so that's using the answer to part A, multiplied by 27, again using the answer to part A, and this is equal to 27. So we have 3 to the negative 2 multiplied by 3 to the 2y plus 1 multiplied by 3 to the negative 4 multiplied by 27, which is 3 cubed, and this is equal to 27, which is 3 cubed. What we can now do is recognize we have the same base on the left hand side and we are multiplying, so we can add the powers. So we have 3 to the negative 2 plus 2y plus 1 plus negative 4 plus 3, and this is equal to 3 to the power of 3. So what we have then is 3 to the, now here we have negative 2 plus 1, subtract 4 plus 3, so that's negative 2, and then we add on to this the 2y, and this is equal to 3 cubed. So, comparing the powers, we have -2 plus 2y equals 3, which means if I solve for y is equal to 2.5. Question number 5. The diagram shows a circle centre O. A, B and C are points on the circumference of the circle. We have to prove that the angle subtended by the arc at the centre is twice the angle subtended at the circumference. Our first step is to join the point A to the point O, like so. And therefore, what we can see at this point is OA equals OB equals OC. The reason for that is they are all radii. And what that means is the triangle OAB and the triangle OAC are isosceles triangles. The reason for that is we've got two lengths which are the same size. So we have an isosceles triangle. Now, there are various angles which we need to work out in this question. So let's work those out. So the first thing we will do is we will let the angle ABO equal BAO equal x. And that's because the base angles of an isosceles are equal. So we can show those here. And similarly, if we let the angle CAO equal ACO equal y, again same reason, the base angles of an isosceles are equal, we can show them on the diagram here. And therefore, at this point, because angles in a triangle sum to 180, the angle BOA is equal to 180 subtract 2x, because angles in a triangle sum to 180, and that's shown here. And similarly, the angle COA is equal to 180 subtract 2y. The reason for that is angles in a triangle sum to 180. We can show that here. Now, the angle at the circumference, that's BAC, is the sum of x and y. So, BAC is equal to x plus y. And what we can now do is find out the angle BOC. That's this angle here. So, that's equal to 360 subtract 180 subtract 2x subtract 180 subtract 2y. The reason for this is angles around a point sum to 360. So if I simplify this result, we get 2x plus 2y, and if I factorise out a 2, we have 2 multiplied by x plus y. But we've said that x plus y is what the angle BAC is. So this angle is 2 times by x plus y, which is twice the angle BAC. So what we are saying here is x plus y is half of the 2 times by x plus y. So we've shown this statement to be true, which means the angle subtended by the arc at the centre is twice the angle subtended at the circumference. Question 6. The point Q with coordinates -2, 0 is on the curve f of x. The transformation f of x plus a plus b of the curve f of x moves the point P from 0, 0 to 3, 4. Part A. Write down the coordinates of Q after the transformation f of x plus a plus b. Now, to go from 0, 0 to 3, 4, we add 3 in the x direction, we add 4 in the y direction. So, we apply that principle to this point Q. So we've got -2, 0 plus 3, 4. That's how we move from here to here. And if I work this out, negative 2 plus 3 is 1, 0 plus 4 is 4, leaving us with 1, 4, meaning the coordinates of Q are 1, 4. Part B, we have to work out the value of A and the value of B. Well, if we are going from 0, 0 to 3, 4, we are going 3 to the right and 4 up. And therefore, the transformation will be given by f of x subtract 3 plus 4. Remember, in the x direction, we generally do the opposite. That is to say, the opposite of plus 3 is negative 3, meaning the value of A is negative 3, the value of B is 4. The transformation k times by f of cx plus 1 of the curve f of x moves the point R from negative 3, 2 to negative 6, 7. For part C, we have to work out the value of c and the value of k. So, in the x direction, we are going from negative 3 to negative 6. Now, negative 3 multiplied by the 2 gives negative 6. Now remember, in the x direction, we generally expect the opposite. So here, as we multiply by 2, what we can infer from that then is c is equal to 1/2. Therefore, c is equal to 1/2. Let's think about the y direction. We are going from 2 to 7. So, I've got this k, and you can think of the f of cx to equal to, it doesn't matter what I put in for the value of x. The point is the output will equal 2. So I've got k multiplied by 2 plus the 1. This is equal to 7 after we apply the transformation, which means k equals 3. So c equals 1/2, k equals 3. Question number 7. A circle C has centre 0, negative 3 and a circumference of 4 pi. For part A, we have to sketch the graph of C. The first thing we can do is find the radius. Well, to find the radius, we have 2 pi times by the radius, and that's equal to the circumference, 4 pi, which means if I solve for r is equal to 2. So I have a circle with centre at 0, negative 3 with a radius of 2. Here is that circle. We've got a centre of 0, negative 3, a radius of 2. The line L has equation 2x subtract y equals 5. Part B, find algebraically the coordinates of the points of intersection of C and L. So let's find the equation of C. Because we have the centre of 0, negative 3 and a radius of 2, C will have equation x squared plus y plus 3 squared equals 2 squared. And to find the equation of L, well, I'm going to rewrite this so we have y equals. Therefore, L has equation y equals 2x subtract 5. And therefore, for me to find out what x and y are, I can substitute in for y 2x subtract 5. So, I have x squared plus, now here I've got y, which is 2x subtract 5, plus 3 squared equals 2 squared. So, I have x squared plus, now here I've got 2x subtract 5 plus 3 all squared, which is the same as 2x subtract 2 all squared. And this is equal to 2 squared, which is 4. So I have x squared plus, now here I've got 2x subtract 2 all squared, so that's the same as 4x squared subtract 8x plus 4, and this is equal to 4. Therefore, if I simplify, I've got x squared plus 4x squared that's 5x squared, and then I've got the negative 8x, and the 4's cancel on both sides, leaving us with 0. And if I factorise out an x, I have x multiplied by 5x subtract 8 equals 0. Meaning, we have x equals 0 or 5x subtract 8 equals 0, in which case x is equal to 8 over 5. We can now substitute these x values into y equals 2x subtract 5 to find the corresponding y values. So we have y equals, well, I've got 2 multiplied by 0 subtract 5, which is negative 5, and I've also got y equals 2 multiplied by 8 over 5 subtract 5, which is negative 9 over 5. So I've got a coordinate of 0, negative 5, and another coordinate of 8 over 5, negative 9 over 5. Here are the coordinates. Question 8. Alex throws a ball to Chris. The motion of the ball is modelled by the equation s equals negative 5t squared plus 20t plus 7, where s is the height of the ball above the ground in meters and t is the time in seconds from when Alex throws the ball. Part A, write down the initial height of the ball. So, to find the initial height, we need to substitute in t equals 0, and clearly when t equals 0, we are left with s equals 7. So the initial height is 7 meters. Part B. Explain why the model is not valid when t equals 5. Well, when t equals 5, s is equal to negative 5 multiplied by 5 squared plus 20 times by 5 plus 7. And if I work this out, I get negative 18, meaning the height would be negative, which is why the model is not valid when t equals 5. Part C, work out the maximum height the ball reaches. To do this, what we need to do is think about our equation s equals negative 5t squared plus 20t plus 7. For us to find the maximum height, we would have to complete the square, from which we can find out what the maximum height is. So, to complete the square, if I take a look at this negative 5t squared and the 20t, I can factorise out a negative 5, leaving me with t squared subtract 4t inside this bracket. And then I add on the 7. So now I can complete the square of this bracket. So I've got negative 5, and if I complete the square of this bracket, well, here I've got a negative 4t, which means I would have t subtract 2 squared. And then I subtract the square of 2, and don't forget we add on the 7. So if I tidy this up even further, I've got negative 5 multiplied by t subtract 2 squared subtract 4, and then I add on the 7. So now we can multiply this negative 5 into this big bracket. So I've got negative 5 multiplied by t subtract 2 squared, and then I've got negative 5 multiplied by negative 4, that's plus 20, and then I add on the 7. So I've got negative 5 times by t subtract 2 squared, and then 20 plus the 7 is 27. So an alternative way of writing s is s equals negative 5 multiplied by t subtract 2 squared plus 27. And if I think about this 27, we can therefore conclude that the maximum height is 27 meters. Chris catches the ball when it is 2 meters above the ground. Part D, work out the total amount of time the ball is in flight. Give your answer in the form a plus root b, where a and b are integers. So what we need to do is set s equal to 2, and then find the appropriate value of t. Now, If I set s equal to 2, I can find out what t is using the result we found in part C. So I've got negative 5 multiplied by t subtract 2 squared plus 27 equals 2. So let's solve for t. If I rearrange, I have 5 multiplied by t subtract 2 squared equals 25. Divide through by 5. T subtract 2 squared is equal to 5. Square root both sides. I have t subtract 2 equals plus minus root 5, meaning t is equal to 2 plus minus root 5. And therefore, we take the positive value of t, which means t is equal to 2 plus root 5 seconds. Question number 9. We've got the vector OA, which is equal to 2a, and the vector OB, which is equal to 3b. C is the point such that the vector AC is equal to 5/3 AB. D is a point such that AD is equal to XA plus YB, and CD is equal to negative 2/3 XA plus 13/33 YB. We have to find the ratio OB to BD, give your answer in its simplest form. Now we will be using this vector OB at some point, so let's highlight it. The first thing we can do is find out what this vector AB is. We are going from A to B, so that's equal to negative 2A plus 3B. Now that I know what AB is, I can find out what AC is. AC is equal to 5/3 multiplied by AB. So I have 5/3 multiplied by negative 2A plus 3B, which is equal to negative 10/3A plus 5B. Now, if I think about the point D and the vectors AD and CD and how they relate, well, I can go from A to D by going from A to C and then C to D. Now I know what the vector AD is. That's given by XA plus YB, and that's equal to the vector AC, which is negative 10/3A plus 5B, plus the vector CD, which is given by negative 2/3 XA plus 13/33 YB. To find out the values of X and Y, what we can do is compare components. So if we compare components, let's take a look at the A components. On the left hand side, I have X, and on the right hand side, I've got this negative 10/3 and this negative 2/3 X, which means I can now find out what X is. So I've got 3x equals negative 10 subtract 2x. 5x is equal to negative 10, which means x is equal to negative 2. We can do a similar thing with the B components. So thinking about the B components, I've got y on the left hand side, and on the right hand side, I've got the 5b and the 13/33 YB. So I have 5 plus 13/33 Y. And if I multiply through by 33, you will find 33y to equal 165 plus 13y. Simplifying, you will find 20y to equal 165, which means y is equal to 33/4. I know what x and y are, which means I can now state what the vector AD is. Remember, the vector AD is given by XA plus YB. So I've got AD equaling negative 2A plus 33/4B. Now, what is the question asking us to do? The question is asking us to find the ratio of OB to BD in its simplest form, so we need the vector BD. And the vector BD is equal to the vector AD subtract AB. I know what the vector AD is, that's negative 2A plus 33 over 4B, and I subtract from this the vector AB, which I know is negative 2A plus 3B. Now, I've got negative 2A plus 2A, that's 0A, and then I've got 33 over 4B plus the negative 3B. So I end up with 33 over 4B subtract 3B, which is equal to 21 over 4B. Meaning, OB to BD is given by 3B to 21 over 4B. If I multiply by 4, I have 12B to 21B, and if I divide through by 3, we end up with 47 in simplest form.